It's my first time in Turkey, actually, so I'm quite excited to be here. Yeah, so my talk today is about improving code quality, but so before I begin, let me just briefly introduce myself. My background is in computer science. I have about 10 years of experience, mainly focusing on native iOS development, and currently I'm a team lead. Most of the content of this talk I basically derived from my experience working on white label products for mobile trading and banking. The main question I want to answer is how we can improve code quality. First, I want to start talking about the expression problem. I'll give an example. Consider that I want to write a program to work with geometric shapes. So I might want to implement a protocol and a few structs using Swift. So fairly standard, right? If I want to add more shapes here, it's really easy. I just create another struct. It conforms to the protocol. Again, it works pretty easily. I don't need to change any of my existing code. If I want to add more functions, however, it becomes a bit more complicated because now I need to I have to make changes across all of the structs which I've implemented. So it's a bit more difficult. In Swift, I might be able to use protocol extensions depending on the kind of functions that I want to add. So in some situations, this makes it easier. But yeah, it really depends on the kind of additional functions that I want. Here's another way in which I could work with the same geometric shapes. So I could define an enum with two cases, and then all of the functions that I need will be defined on this enum. And here, if I want to add more functions, it's actually really easy. So I could just extend the enum. I don't need to change anything of the existing code. But if I want to work with additional shapes, I kind of run into a difficult situation again because adding a triangle basically extends my enum, and I need to handle this new case in all of my existing functions. So this is the expression problem. And well, the question is, do we have a solution? So we could mitigate the problem using protocol extensions in Swift. There's similar constructs in Kotlin and probably in other languages, more modern ones. But at its core, it's unsolvable. So the way that we could mitigate it is basically to avoid the need for cross-cutting changes. And so we need to be careful how much behavior we attach to our objects. And we need to think really carefully about the kind of extensibility that we'll expect in our implementation. I will talk about cooking now for a bit. Consider the recipe for pancakes. Basically, I have a list of ingredients and a list of instructions. So no need to get too much into details. I'm not good at cooking, actually. And because of that, I'm going to write a program that could actually maybe cook the pancakes for me. So here's how it could look like. Pretty standard again. So I have, objects for all of my ingredients, have an object for my pan, for all of the utensils and all of the ingredients that I need. But there are a few problems here. So first we have mutable state. And if we're going to do testing, this might make it a bit difficult for us. There are also some implicit dependencies between the steps. So the question is, are there any steps that we can actually do in parallel, and which are those steps? It's also not obvious if any of the functions are blocking, because maybe it takes some time for my pan to heat up, or maybe some other operation takes more time than I would expect. And it's, there's no error handling here. There's no exception. So if something goes wrong, then I will need to add some additional logic here, and then this flow will get way more complex. So how can we improve this code? It makes sense to think of this recipe in terms of data flow. So I could start with the list of ingredients, and then at each step, I could define a function for the operation that I need. So first, I have step one, I have the sieve function. It takes the flour as a parameter. And then at step two, I take the result of the sieve function and I combine it with the salt and I pass them to the stir function. Then at step three, I have beat function, which takes the output of step two and combines it with the eggs. And probably in parallel, I could melt the butter, so I could pass butter to my melt function, and so on. I think you get the idea. So the good thing about this is if at some point I get an error, I can really easily spot it. And it makes it also really easy to determine which operations I need to do again. So can we rewrite our recipe implementation using this approach? This is what a sample implementation could look like. Of course, someone will need to implement all those functions, but well, it's also a bit of a fictitious example. But as you can see, it's really easy to follow the flow, and I actually have the opportunity here so if at any point an error occurs, I have the opportunity to pass that error to the next function and decide how to handle it. We also need less integration testing here because it's really easy to spot some inconsistency with the recipe just by reading the code. So it's much more readable. So what is the answer then? How to improve code quality? Well, we need to avoid doing cross-cutting changes and write reusable functions, right? So everything is solved. But so how exactly can we do that in practice? So I think it helps so a good software system will have individual components. And I think it helps a lot to think about how Lego works. How many of you have actually played with Lego? Yeah, okay. Some people at least. Well, so you've seen it, right? So, we have many different Lego parts that can be combined in different ways, and then you can do all sorts of different structures with it. A good software design would be very similar to Lego. But in order to apply, in order to have the same kind of a good structure in a software system, we need to think about how to create these components. So a good software component can be characterized using these two terms, cohesion and coupling. So we can have high coupling, low coupling, or low cohesion and high cohesion. So as you can see here, when cohesion is low, we end up with a system that resembles a kind of a puzzle. And whether it has high coupling or low coupling, well, it makes a certain difference, but it's still sort of a puzzle. So we want to aim to have high cohesion and low coupling between our components. This is actually an example. It's a real-world example that one of my colleagues found when debugging an iOS application. So I don't know if you can see clearly, but all these 6 objects are, they're actually interrelated in some way, and they end up retaining each other. So they end up creating a memory leak. And this is what happens when cohesion is lost. We end up with, these kinds of situations, and they're not easily solvable. We just need to rewrite, all these. We need to throw away these objects and rewrite them. So how to write reusable code? So we need to ask ourselves one of these 2 questions. Basically, can we use it for a different purpose, or can we apply it in a different context? We can ask those questions for mostly any piece of code. It could be a class, it could be a functions or a set of functions. If we can use it for a different purpose, then we need to identify what those other applications are. And if it can be used in different contexts, we need to figure out what are the minimum set of dependencies for our piece of code. And here you can think about, again, the recipe that we wrote for pancakes. So we have these set of functions that can work on different ingredients that we use. So if we are able to identify other applications, then we'll probably be able to extract some useful data structures, and we can call them, or we can put them into our domain logic. On the flip side, if we are able to identify the important dependencies, we could try to isolate certain functions, and we can characterize them as what I want to call interaction logic. In some cases, it's also called services. It depends on whether you have, let's say, a server application or a GUI application. So there might be certain difference, but the fundamental idea is the same. So what does the domain logic look like? Most of the time, those will be just objects that contain some domain-specific behavior. And they will be, most of them will be named, they will use some names that come from your business domain. So if you're writing a banking application, probably you have accounts, transactions, orders, these kinds objects. And for these objects, you need to aim for informational cohesion. So you need to really think how best to store the information in them. For the interaction logic is, again, a bit of a flip side. Most of that will be some algorithms or sets of functions that basically aim to do the same kind of actions. The names here can be a bit more abstract. Again, this really depends on the kind of use cases that you have. In a GUI application, most of that will be UI logic. For example, in a mobile application, it will be using a lot of functions from UIKit and so yeah, here you need to aim for functional cohesion. But so can all the code be made reusable in this way? In some cases, the answer might be no to both of these. So then what do? We have some piece of code that is single purpose and the context is really specific, so we cannot make it reusable, right? We can call this application logic because most likely it implements a really specific use case. And here the cohesion will be a bit lower. So here we could only aim for communication or sequential cohesion. Again, just with a pancake recipe example, well, if I change something in my functions there, well, I will probably no longer end up with pancakes. I will end up with something that maybe cannot really be put on the table. So again, if we go back to the first diagram, trying to make our logic reusable, we can, of course, we need to be careful a bit. So we need to be careful how we create our abstractions. Yeah, because we could also end up basically shooting ourselves in the foot, trying to create, too complex abstractions, or if we create too many shared types. So all this needs to be done carefully, of course, and you need to consider the domain in which your product will be useful. We've been able to apply these ideas into mobile development, and this is a demo of a trading app that I worked on at my previous project. We basically rewrote large parts of this UI to be able to achieve this kind of smooth animations and make it really much more responsive. All of this information, by the way, is also live data. So the prices which you see, for example, in the first screen for the instruments, they can actually update in real time at any point. So that's it. If you scan the QR code, I've prepared a list of useful links, and some of them are talks, some of them are articles. Some of them are just, going to a bit more detail. What is cohesion? What is coupling? And how to think about these things in more practical details. Okay, thanks.